Semiconductors Theory. Semiconductor. A semiconductor is a substance which has its resistivity in between the conductors and insulators. Example: germanium, silicon, selenium, carbon, etc. Semiconductors has a lattice structure or a crystalline structure in nature, where the atoms are arranged in an orderly manner. Resistivity of semiconductors. As seen in the table, the resistivity of germanium is 4.6 into 10 power minus 1 ohm meter and silicons is 6.4 into 10 power 2 ohm meter, which is higher than the conductors like silicon, whose resistivity is 1.6 into 10 power minus 8 ohm meter, and so on. However, the resistivity of semiconductor is quite low compared to insulators like glass, whose resistivity is 1 into 10 power 10 ohm meter, and so on. Properties of semiconductors. Firstly, the resistivity of a semiconductor is less than an insulator but more than a conductor. Secondly, semiconductors have negative temperature coefficient of resistance, that is, the resistance of a semiconductor decreases with the increase in temperature and vice versa. For example, semiconductor like germanium is actually an insulator at low temperature, but it becomes a good conductor at high temperature. Thirdly, when a suitable metallic impurity materials such as arsenic, gallium, etc. are added to a semiconductor, its current conducting properties change appreciably. Bonds in solids. Bonds are mainly classified as ionic bonds, covalent bonds, metallic bonds. First, ionic bonds. This bonding occurs between two different atoms and are due to permanent transfer of valence electrons from one to another. It's a very strong bond. Such bonds are formed between sodium and chlorine atoms during the formation of sodium chloride, that is NaCl crystals. Second, covalent bonds. The atoms of every element are held together by the bonding action of valence electrons. This bonding is due to the fact that it is the tendency of each atom to complete its last orbit by acquiring 8 electrons in it. However, in most of the substances, the last orbit is incomplete, that is, the last orbit does not have 8 electrons. This makes the atom active to enter into bargain with other atoms to acquire 8 electrons in the last orbit. To do so, the atom may lose, gain, or share valence electrons with other atoms. In semiconductors, bonds are formed by sharing valence electrons. Such bonds are called covalent bonds. In the formation of covalent bond, each atom contributes equal number of valence electrons, and the contributed electrons are shared by atoms engaged in the formation of the bond. Figure shows the covalent bonds among germanium atoms. A germanium atom has 4 valence electrons. It is the tendency of each germanium atom to have 8 electrons in the last orbit. To do so, each germanium atom positions itself between 4 other germanium atoms as shown in the first figure. Each neighboring atom shares 1 valence electron with the central atom. In this process, the central atom completes its last orbit by having 8 electrons revolving round the nucleus. In this way, the central atom sets up covalent bonding of germanium atoms. Figure shows the covalent bonds among silicon atom. A silicon atom has 4 valence electrons. It is the tendency of each atom to have 8 electrons in the last orbit. Hence, each silicon atom positions itself between 4 other silicon atoms as shown in first figure. Each neighboring atom shares one valence electron with the central atom. In this way, the central atom completes its last orbit by having 8 electrons revolving round the nucleus. Hence, central atom sets up covalent bonding of silicon atom. The following points may be noted regarding the covalent bonds. Covalent bonds are formed by sharing of valence electrons. In the formation of covalent bond, each valence electron of an atom forms direct bonding with the valence electron of an adjacent atom. In other words, valence electrons are associated with particular atoms. For this reason, valence electrons in a semiconductor are not free. Thirdly, metallic bonds. These bonds exist in metals and their alloys. As we know, alloy is a mixture of two or more metals. They arise due to sharing of variable number of electrons by a variable number of atoms. It has been found that in metals like copper, each atom loses its valence electron at room temperature and becomes positively charged ion. These free and mobile electrons form a kind of electron cloud or gas which permeates all atoms.